You know, every smartphone, every computer, pretty much every piece of smart tech you own, it all runs on a tiny, incredibly powerful microchip. But what if I told you the company that makes all of this possible is a name you've probably never even heard? Well, today we're going to pull back the curtain on a hidden giant that holds the keys to our entire digital world.
So, let me ask you a question. When you think about where a microchip comes from, what pops into your head? For most of us, right, it's probably some giant, super clean factory, maybe a place like TSMC in Taiwan, with all the workers in those white bunny suits. But here's the thing. That's not the whole story. It's not even close to where the story actually begins.
You see, those massive factories, they're called foundries, are really just that. They're the builders. They execute a plan, an incredibly complex instruction manual for a chip that someone else gives them. So the real question, the one we need to ask is, where does that plan come from?
It all starts with the design. Long before any silicon gets touched, an impossibly intricate blueprint has to be created, and that's where we need to look first.
Think about it this way. You can't build a skyscraper without architectural plans, right? It's the same idea in the world of semiconductors. Every single processor, every memory chip, every piece of advanced silicon starts its life as a digital blueprint.
Now, just let that quote sink in for a minute. This is what Moore's Law has given us, that relentless doubling of transistors on a chip every couple of years. We are not talking about a simple little schematic anymore. We're talking about a layout with billions, sometimes trillions of tiny transistors that all have to be placed and connected perfectly. It's a level of complexity that is, well, it's literally beyond human comprehension.
So how on earth do you manage something that complex? You need some incredibly powerful, specialized tools. And this is where a category of software called Electronic Design Automation, or EDA, comes into play. EDA is kind of like the magic wand that lets engineers design, simulate, and check these city-sized digital blueprints before a single dollar is ever spent on manufacturing.
Which leads us to a really fascinating question. If every single chip designer out there, we're talking Apple, NVIDIA, Intel, all of them, if they all need this critical EDA software to even exist, who makes it? Who builds the software that builds all the hardware?
For a huge portion of the entire industry, the answer is a single company you might not have heard of, Synopsys. They are the invisible architects behind the chips that power, well, everything.
This is honestly the perfect way to think about what they do. Synopsys isn't just one application or one tool, it's the whole foundational platform. If chip design were a computer, Synopsys would be its operating system. It's the fundamental environment where all the real design work actually gets done.
Okay, so when one company has such a central, foundational role, it's pretty natural that they end up with a dominant market position. But what's so fascinating about Synopsys is how they built their monopoly. It wasn't through a bunch of aggressive takeovers. It was through something way harder for anyone else to overcome. This quote from the source material just says it all. The barrier to entry here isn't just high, it's like an impossibly tall, complex mountain. Potential competitors take one look at what it would take to even start climbing it, and they just turn around and walk away.
Yeah, this comparison really puts it all into perspective. I mean, think about starting a car company. It's incredibly hard, requires billions in capital, but it's a problem of physics and manufacturing. To compete with Synopsys, whoa, you'd need to replicate decades of interlocking code and then convince an entire industry of engineers to ditch the tools they've used for their entire careers. It's a totally different, and you could argue, a much harder challenge.
So how does this incredible market position actually translate into a business? Well, it's one of the most elegant and powerful business models in all of tech. Okay, so this is where their business model gets truly brilliant. Synopsys doesn't just sell the design software, they also design and license reusable chip components. This is what's known in the industry as intellectual property, or IP. Think of these as pre-built digital Lego bricks for common things like a USB port or a Wi-Fi connection. Chip designers pay to use these Lego bricks in their blueprints, and here's the magic part, Synopsys gets a small royalty on every single chip that's made using their IP.
So when you combine their software dominance with this IP royalty model, I mean, the result is staggering. They get a tiny slice of the value of a massive portion of the world's most advanced electronics. It is, for all intents and purposes, a digital toll booth on the highway of technological progress.
So when you put it all together, the picture becomes crystal clear. Every modern chip starts as one of these complex digital blueprints.
Synopsys provides the essential operating software to create them. Their competitive moat isn't built with money, it's built with pure accumulated software complexity. And they cash in not just by selling the software, but by collecting those tiny royalties on the very building blocks of the chips themselves. And that leaves us with a final and pretty crucial question. Our entire digital world is constructed from these blueprints, and as we've just seen, one company has an unprecedented hold on the very tools used to draw them. So what does it mean? What happens when a single, little-known entity holds all the keys to the foundational architecture of our future?